We're going to do a lesson here. We're going to call it 2-0.5. It's coming before lesson 2.1. And this is going to be on learning a little bit more about combining like terms and solving equations. So we've talked about it last year already, but just a refresher. When we talk about like terms, so what are like terms? Well, one thing like terms could be is just constants, just plain numbers. Like 8 and 4 are like terms. -3 and 5 are like terms. Okay, they're just constants. They're just plain numbers. Besides constants, we can also have variable terms. So for example, 4x and 5x are like terms. -3y and 7y are like terms. An example of something that's not like terms, kind of a non-example, 4x squared and 5y squared are not like terms because they have different variables. Okay, so if they're just plain numbers, those are like terms. If they have variables, the variable part has to be identical for them to be like terms. And as we look at this, the question might be, well, what's the big deal about like terms? Why do we care about like terms? The reason we care about like terms is when we're working out a problem, if we're simplifying an expression or if we're solving an equation, we can combine like terms. We can combine them together. We can add them or subtract them and combine them together, and that's going to make our expression more simplified, or it's going to make it easier for us to solve the equation. So we're going to go through on solving some equations, and we're going to start and kind of gradually work our way up. Okay, we're going to start with simpler equations, and we're going to work our way up to more difficult equations. So what we're trying to do on this first problem is we are trying to solve for x. We're going to try and figure out what x is equal to. I know on some of these problems, some of you may be able to look at this and say, oh, I know what it is. I figured out what x is equal to. That's great, but I still want you to show your steps, because there are problems that are not always going to come out evenly, and you're not going to be able to just look at them and tell what the answer is going to be. So you are going to need to show your work. You're going to have to show your steps of what you're doing to solve for these equations. So on a problem like this, kind of our first step, this is called a two-step equation because there are two steps for solving it. The first thing we're going to be doing is we're going to be trying to get the variable term by itself. By the variable term, I mean the 3x. Okay, we're going to try and get that by itself, and then we'll have at that point one more step, and then we'll be able to figure out what x is equal to. When we're doing these problems, you'll notice we will be doing opposite operations in order to cancel things out. So in order to get the 3x by itself, on the same side of the equation with the 3x, they're adding 5. So to get rid of them adding 5, we need to subtract 5. We're going to do the opposite operation. The opposite of adding 5 is subtracting 5. And when we do this equation, it's like a balance. If these things are equal to each other, if I take away 5 from one side and I take away 5 from the other side, they're still going to remain equal to each other. Okay? We have to do the same on both sides of the equation in order to keep it balanced. Okay, so you can kind of imagine, I don't know if you want to actually draw this on there, probably not, but imagine this dotted line, and you got to do the same thing on both sides of the dotted line to keep your equation balanced. So when we do that, 5 minus 5 is 0, so you can just cross those out. And then on the other side of the equation, 8 minus 5 is 3. So that's our first step. At this point, we just have one more step, and we'll be able to figure out what x is equal to. So if you'll notice on this step, the 3 and the x are right next to each other. And what that means when they're right next to each other, it means they're being multiplied. You can put parentheses around one of them if you'd like, they're being multiplied, and so to get rid of that, we can divide by 3. Basically at that point then, 3 divided by 3 is 1, so you can just cancel those out if you want. And then on the other side, 3 divided by 3 is 1. So x equals 1 would be our solution to this equation. The nice thing about doing these problems is if you have time, you can go back and check your answer. You can substitute, we got x equals 1. You can substitute that back into the equation and make sure that it works. So when I do that, I'm going to put a question mark here above the equal sign because I'm checking to see whether these are equal or not. So 1 in place of the x, 3 times 1 is 3. And then the question is 3 plus 5 equals 8. Is 3 plus 5 equal to 8? And it is. So then I know I have the correct answer. So the next problem, kind of like a video game here, we're working with the next level, so things get a little bit more challenging, progressively more challenging as we go. So this problem is a little bit different, so we're going to look at this, and we're going to be actually still able, though, to figure out what x is equal to. So this problem, you may notice there are 2 x's, there are 2 variable terms in this problem. And so what we're going to be doing is really the first step on any problem that we do is we're going to try to see whether we can simplify things on one side or the other of the equation. On the right side, all we have is an 11. So if we just have an 11, there's nothing we can do to simplify that down anymore. On the left side of the equation, though, we do have some like terms. We talked about like terms earlier. And the like terms, if they're on the same side of the equation, we're going to be able to combine those together. So in this case, the 2x plus 5x, we're going to be able to combine that. And by doing that, we will have a 2-step equation just like we worked in the last problem. So kind of like 2 plus 5 is equal to 7, 2x plus 5x is equal to 7x. If you have 2 times something, and you have 5 times something, that's the same altogether as 7 times something. So now we've got 7x minus 3 equals 11. We have a 2-step equation like what we did in the first problem. At this point, we're going to try and get our variable term by itself. So the 7x, we're going to try and get by itself here. Since they're subtracting 3, we're going to add 3 on both sides. Okay, if you want to think of it as like -3 plus 3 is 0, if that's a way of thinking about it, or you can just say they're subtracting 3. So if you take away 3 and then you put back 3, then you're back where you started with. And then 11 plus 3 is equal to 14. And then our last step there, multiplying by 7, so we can divide by 7. And when you divide that out, would be 2. So x equals 2. Just like we did on the last problem, if you have time, you could go back and check this answer. The difference here is that we have 2 places we would be substituting in for our x because we had 2 different terms. So once we get that, substitute it back in. We know we have to do multiplication before we add or subtract anything, so if we just do the multiplication and then add and subtract from left to right, so 4 plus 10 is 14, and then 14 minus 3 is equal to 11, and so I know I have the correct answer to that problem. So third problem, very similar to the last one we just looked at. So once again, we have like terms on the same side of the equation. We have 2x minus 1x. One thing we want to make sure of, if we're looking at these, you need to remember that the sign is to the left of your term. So that's a positive 2x. It is the same as 2x, but we just need to watch that, because if it said minus 2x, we would need to look at that as being a negative 2x. Okay, so that's the thing we really have to watch for. So on this problem, then we've got 2x minus 1x, which would be 1x. 2 minus 1 is 1, so 2x minus 1x is 1x. And at this point, we have, once again, a two-step equation. This one might look a little different to you just because we have the constant first and then the variable, the constant term and then the variable term. Since they're being added, you could switch them around if you wanted to, but if it doesn't bother you too badly, we'll just keep it in the same order as it's in right now. So at this point, we're trying to get that 1x by itself. This is a positive 4 out here, so to get rid of a positive 4, we need to subtract 4. It's kind of like they added 4, okay? Like I said, this is really the same as 1x plus 4. It's just in a different order, okay? So they're adding 4, we can subtract 4. And then 12 minus 4 is 8. At that point, we have 1x equals 8. 1x is really the same as x. So we're technically done at that point. If you'd like to, you can say they're multiplying by 1. I'm going to divide by 1, and we'll still get 8. Okay? So autopilot mode especially, you know, you may just say, okay, next step, last step, I need to divide by whatever, and then get my answer. And then once again, we could substitute that back in the original problem and find out that we have the correct answer again. Our fourth problem here, just slight difference, couple slight differences, I guess you could say. One thing is we have an extra term. We have 4 terms on the left side of the equation instead of 3. And then we have one other thing that's a little different here that we'll be talking about as we go through the problem. So first thing we're looking for, trying to simplify both sides of the equation. So we're looking for like terms. So on the left side of the equation, we have 2 terms that have x's in them. And like I said earlier, the sign that's to the left goes with the term. The other thing you can do, if it helps you, you could add the opposite there. Remember on subtraction problems with integers, we talked about adding the opposite. So that's like 3x and a negative 9x. So when you do that, if you want to think of it over here, this is like 3 plus negative 9 if you want to rewrite it. So that helps you to think about what you're doing and what your answer is going to be. You can do that. If you're able to just come up with it without rewriting it, that's fine too. So 3 plus negative 9, these are different signs. They're working against each other. We have more that are negative. So that would be a negative 6x. We have another set of like terms over here. We've got a 2 and a 3. They're both positive, so a little bit simpler maybe. 2 plus 3 equals 5. And at that point now we actually have a two-step equation again. So next, to try and get that variable term by itself, to try and get the negative 6x by itself, you can see they're adding 5, so we can subtract 5. I put the box around the negative 6x. You're welcome to do that if it helps you. You don't have to do that though, okay? So the steps I'm doing, please do, but you don't on that step have to put the box around the negative 6x. So at that point, 7 minus 5 is 2. And we got one step left. So they are they're multiplying x by negative 6. So if they're multiplying, we would need to divide by negative 6. So I intentionally created this problem this way just to show you things don't always come out nicely. A temptation for some people might be to take 6 divided by 2. That's not what we have. We have 2 divided by negative 6. One thing to notice is we have a positive divided by a negative. So our answer is going to be negative. I'm going to put the negative sign up in the numerator. You can put it either place, but I just like to put the negative in the numerator. And then 2/6 is less than 1, so we can reduce that, but it's not going to be a whole number answer. So -1/3 would be the answer for this problem, okay? So just to illustrate to you that these answers are not necessarily always going to come out as just a whole number or an integer. You're going to have fractions or decimals sometimes that you'll have to contend with as well. So this problem to start out with, we don't have any like terms that we can combine on either side. On the left side, those are not like terms. On the right side, we only have one term. So our goal then, since those both sides are already simplified, our goal is to get this part with the variable by itself. So we can see that they're adding 7 to that. So if they're adding 7, we need to do the opposite operation, and we need to subtract 7. 7 minus 7 is 0, so those cancel out. And then 9 minus 7 is 2. At that point, we only have one more step, and we will figure out what x is equal to. So on this step, a little different than the problems we've looked at so far, the variable is being divided by 5. And so if they are dividing by 5, we need to multiply by 5. If you want, you can put this as a 5/1, so you can see that those 5s are going to cancel. You could multiply across and get 5x over 5 and then divide it out and get 1x. But ultimately, the 5s basically cancel each other out. And so then 2 times 5 is 10. And once again, we didn't show it on all the problems, but we could, once we get that answer, we could show checking that solution again, just to make sure we got the right answer. So 10 divided by 5 is 2, and 2 plus 7 is 9, so we know we have the right answer. So this gives you a little bit of an idea of how we can combine like terms and solve equations. Have a good day.